Welcome to video 5 in the Build Your Own AI series. In this one we're going to be looking into how to add chat capabilities to our AI. Now in the previous video we finalized the code to get our AI to detect motion on the Raspberry Pi, to check for a person in the image, and then to respond with voice back on our Pi. But simply saying hello is not much evidence of intelligence, so we're now going to discuss how we might enhance the chat capabilities of our AI. Simple chatbots tend to be designed around a question and answer model. They try to identify the intent of a question. Natural language understanding models can be used to ensure that however the question is phrased, the basic intent is still the same, and can therefore be matched to a pre-prepared response or action. I was initially considering this model and thinking of using the Python SpaCy library as a way of extracting the intent. This is a good approach for, say, a home automation system, and when I last looked into Alexa skills, it was essentially how Alexa worked. In fact, Alexa required very specific spoken requests and didn't use any NLU at all. I don't know if that's changed more recently. So you don't need a lot of smarts for the question and answer model to be useful, but you can end up with a very boring robot, as the canned responses can seem predictable and repetitive. This can be resolved, however, by introducing some level of randomness in the responses. Take for instance these two chains of short sentences, which are example greetings. If we look at these as Lego blocks of conversations, we can categorize them, and then we can choose a random value from each category when we perform a greeting. So with just these three parts and two options in each category, we can create 8 possible greetings. This was how I designed my previous AI named Meebo. I also created chains of sentences that led to simple questions Meebo would ask. The answers given by the human would then lead the conversation down different paths, kind of like those choose-your-own-adventure stories. This choose-your-own-adventure model required even more work to set up though, as multiple responses were required for most scenarios. While doing some research into different chatbot options for my AI, I encountered a video by a guy named Suraj Raval explaining how to develop a more generalized conversation model using machine learning. His videos are very entertaining and very informative, and he prepares a great deal of content to back them up, including code. The idea behind the generalized conversation model is to train a machine learning model on a large dataset of real-world conversations. If the dataset is large enough, the model will recognize patterns in the back and forth dialogue and can then intrinsically know that when someone says, "I don't feel well today," a suitable response might be, "You should see a doctor." So where to get a suitably large set of conversations to build such a model? Well, Suraj points out that movie dialogues can be used, and there's a downloadable dataset readily available. Of course, you run the risk of it responding entirely randomly if a verbal exchange is not a scenario it learned from the training dataset. The other limitation of the generalized model is that it requires an input phrase to trigger a response, whereas my choose-your-own-adventure model just allowed you to trigger a conversation from any starting category code, which is what we want if our AI is to trigger a conversation when, say, motion is detected. So I think, therefore, I'll try a combined approach to get the best of both worlds. When recognized phrases are detected, we can leverage known responses and actions from our responses database. We can also trigger the start of a conversation using a specific code in that database. When unrecognized phrases are detected, we can leverage our generalized model, and hopefully a valid response is the result. This gives us the utilitarian approach of a standard chatbot and the flexibility of a true AI when we need it. I can readily set up our database of responses and trigger it from our client motion sensor code, as I have that database from my pre-existing Meebo setup. And we can build our generalized model later on. We're going to use Docker to set up our database server. Now we'll want our database server to persist its databases on our hard disk, so we're going to map the database's location on our Docker image across to an actual directory on our PC. So we'll use the make directory command here in Linux to create a directory, and then the docker run command, as you see here, to create your Docker image, passing in the mapping of the location where the databases would be, and also mapping of the ports there, so we can access the port externally from our PC. We won't need to access it across the network, so we don't need to assign the IP or worry about that here. The Docker container will be running by default after the docker run command, but if you need to start the Docker container again at any time, you can just type in docker start robotai-MySQL. Now that we have our database server, we'll want to upload our data, our database backup, which will contain all of the values inside a table there we can leverage for the chat paths. Download that from GitHub, which will be located in the database subdirectory there, and copy that to that folder that we've mapped to our image. To connect to MySQL inside the Docker container, type in docker exec interactive terminal command there, -IT, to get to an interactive terminal, and you should see your cursor change to something like what is shown here. Then we can restore the database to create our new robot AI database. So enter MySQL command here. If you get an error, it may be that the database is not being created automatically, so just type in a create database robot AI command in order to resolve that issue. Then you can log into MySQL and check the data. So type in MySQL with username, root, and password. It'll prompt you for the password. Your resulting cursor will look something like MySQL with a greater than sign after it. Enter the following and hit enter afterwards, show tables, and then semicolon, and that should show you that our table exists in the database. You now have your database server that you can run at any time when we're running our brain. Just as a reminder, you can exit MySQL with this particular command here. So in the next video, what we will do is build our Python logic to be able to query this database. If you want to be notified when the next video is available, then please click on subscribe, and thank you for watching.